Hello and welcome to topic 3B, where we are battling the calculations and looking at an example that reinforces the concepts that we learned in video 3A, but we have done one by hand. This time, thank goodness, we can use just a more convenient calculator that is our spreadsheet. I don't want to, on purpose, use all the functionality of Microsoft Excel for two reasons. Because we have a dedicated statistics software package, and we make videos on that one separately, SPSS. And not everyone might use the same spreadsheet software. Some might use Google Sheets, Open Office, whatever you may have access to. So I try and do it in a way that just uses the bare essentials uh, in terms of conveniences that a spreadsheet offers. So for our purposes, it is just a glorified calculator, but with that comes a ton of conveniences. So let's have a look at this example. I just wrote up a small one, didn't make it too wordy, but could be quite relevant. And I just made up the numbers as well. We want to calculate the odds ratio, and we're actually going to do everything else as well for practice sake for the following study, which investigated the effectiveness of a certain vaccine in preventing a virus. And we got this information from our study. 200 tested negative when they didn't have any vaccine treatment. 50, and now I'm not incorporating the correctness of the test. Multiple tests have been done. They are negative. They don't have the virus, and they didn't receive any vaccine treatment. That, of course, can happen. 50 tested positive, meaning they have the virus, even though they did get the treatment. That's also possible because the vaccines aren't perfect, right? 130 had the virus and they didn't get a vaccine treatment. 85 tested negative, so no virus, even though, and they got the vaccine treatment. So all I did in Excel was start the table like so. I left myself a little bit of space on the left because that is where I'm going to make my list of all the statistics that we're going to calculate. So we have this information. The vaccine is the treatment, which I can also see as the risk factor. Not getting the vaccine is potentially placing you at risk for getting the virus, more so than getting the vaccine. But regardless, there is always a chance of getting this virus, of getting sick, right? So in both cases, there is some people in all possible categories. The question is, how does the treatment affect my chances of getting the virus? What happens, relatively speaking, being exposed to this risk factor? So for consistency, I'll put the lack of the treatment is in the top row because that's our risk factor, essentially, being exposed to the risk. And we just have to fill in these total cells. Now, we can just add them up. I'm not going to do it there. I'm going to do this row first so it doesn't hide some of the cells. We can say 130 plus 200. Nothing wrong with that because none of these are going to change or anything. But I want to get used to the convenience of a spreadsheet for when it matters. That instead of putting in the numbers I see, I will reference the cell with that number in it. I'll say, take this cell's value and add it to that cell's value and do that. It's exactly the same effect, but in some cases, it's much more convenient to reference the cell with the number instead of copying the number, because now for some reason I see, oh, I have a typo here. It was 135. This doesn't change because it's still, I copied the number. Let me just undo that. It's actually 130. Or I see here, oh, it wasn't 50, it was 55. Now, because of my more sophisticated calculation referencing cells, it'll update and I don't have to redo anything. But those are the numbers. I'll finish the columns to reference that cell plus. See, sometimes when I zoomed in, it can't see the cell. Then is just restart this and start typing in my formula bar, and that won't obscure any cell information. So that cell plus that cell, great. I don't have to actually retype this. I can just copy the formula over and copy the formula over again because I want to add up the totals as well. So there we go, all our numbers. So a total of 465 people were in this study. All kinds of combinations. Some had the vaccine, some didn't, some had the virus, some didn't. Let's figure out what the information suggests. And I'll just do everything. I'll ignore the question that is asking for only the odds ratio. I want to practice, I want to do it all. But a question might not ask for absolutely everything. So be aware of that. First up, I'm going to write them out. Absolute risk. And I will do it like this. I'll say AR, be a small e. It looks like the word. Not the word. AR, maybe big E. There we go. Bold this column as well. It's the answer. Okay. So the absolute risk for the exposed group. Now, just to clarify here, I'll put vaccine up there and I'll say in brackets here, exposed. You're exposed to the risk, not exposed. Why is that bold and the other one isn't? I don't know. Just for consistency, I want to see a vaccine or a treatment in the same way as the risk factor, but it's kind of flipped. So the absolute risk for the exposed group is going to be, remember, within that row, 130 out of 330. I'm not going to put the number in, I'm going to reference the cell. 130 cell divided by the total, and I want to make it, I'll show both. I'll show here the decimal, and where appropriate, I'll show the percentage. So there, I'll just take that one times 100, right? Nothing to it. I, on purpose, will not use the percentage format. There is a percentage format. If I go to number, I don't like that. Just like the percentage button on the calculator, it does the times 100 for me. I get the nice percentage symbol. I don't need that at all. I can put a percentage symbol there if I want to. There we go, percentage, right? I do, however, want to format this cell to maybe only show a couple of decimals, maybe 2 decimals, and we've discussed all of this in a previous video, right? And maybe in the decimal version, I want to see maybe 4 decimals. There we go. Understanding that Excel will keep the true, most accurate numbers in the background. And a big convenience is that I don't have to see them. I don't have to type them again. I don't have to do anything. But I still have to tell it what to calculate. It's just a glorified calculator. So the absolute risk of the non-exposed group will be the number of people with the positive outcome that have the virus divided by the total in that non-exposed group. And I'll set a percentage again. Yes, I can copy the formula. I'm just clarifying here. Copy that guy down to have my percentage symbol in case you want to see. All right. So at this stage, I like to pause and just think, what is happening here? Of course, this is just fictitious data, right? Let's see. So being exposed, not receiving the treatment, I have a 39.39% chance of getting the virus. Receiving the treatment, I have a 37% chance of getting the virus. So they're very close to each other. However, not receiving the vaccine treatment does, according to this, result in an increased chance of getting the virus. However slight it might be, sometimes it's not a big difference. Sometimes it is. Our previous example that we did by hand, we saw quite a difference. This one, very small difference, but there is a difference. And now we want to express that difference in a variety of ways, essentially. So it's good after the absolute risk calculations to just pause and say, let's look at what we have here. Relative risk. Space here, relative risk. Let's calculate it. All it is decimal version. It is the ratio, the bigger one divided by the smaller one. Now, some people say it's always one divided by the other. I like to make my interpretations easier. And for me, interpretations are easier if the relative risk is above 1. So I'm always going to take the bigger one divided by the smaller one, and then just adjust my word interpretation accordingly, understanding which one I did. Not the only option, but I find people struggle with, let's suppose the top one was smaller. Then when I divide by a bigger number, I get a fraction, or I get a decimal less than 1. People struggle to interpret that when I compare that to a number greater than 1. And I can interpret it in multiple ways. That's going to be what I go for. I'm going to skip the percentage in this case because I personally perhaps get confused with this specific percentage. And I find that's a little bit of a sticky point, and I don't need to interpret it like that. So the relative risk is indicating what I suspect, that my chances of getting the virus, if I don't get the vaccine, is 1.06 times higher than if I do get the vaccine. I expected a number just above 1 because the two percentages were so close. That's fine. It's totally fine. It's going to happen sometimes. The data that I collect with the intention of finding something amazing might not be that. All of that information, right? But I still want to interpret it. Absolute risk reduction. See how easy the spreadsheet is. Oh, just typing, everything is neat. Oh, sorry. Absolute risk reduction, that's simply the one minus the other one, the arithmetic difference, if you will. I want to do an equal sign here. Now I can go decimal, big minus small, or I can go percentage root, big minus small. And again, some books might tell you always the exposed minus the not exposed. I find it makes interpretations easier if I take big minus small. And let's put a percentage sign there. So what does that mean? I have to be always able to interpret this. So if I didn't care about the vaccine at all, taking the vaccine, not taking the vaccine, there is a chance of getting the virus. But not taking the vaccine gives me a 2.3% chance in addition to the quote unquote baseline normal situation. Or, interpreted another way, it's the same way really, just said another way, is people that, from the people that do not take the vaccine, there are 2.35-ish percent of them that get the virus when the treatment could have avoided it. Okay, so important, be able to interpret all of these statistics that we calculate. Next up is the relative risk reduction, where I take this absolute risk reduction and I simply express it relative to the percentages and probabilities that we are working with. An absolute risk reduction of 2.3% might be huge if my initial probabilities were just a few percent. So I have to look at absolute and relative. I have to look at the big picture. I can't just isolate one of these statistics and jump to conclusions. So I will calculate. It is the absolute risk reduction relative to, so divided by the smaller of the two. In this case, it's not exposed. It's the taking the vaccine one. Now there is another way to do it, but we'll mention that in a second. I can do the percentage version, take the absolute risk reduction percentage relative to the smaller percentage, which would be the not exposed group. Oh, I want to make that a percentage, right? Oops. That by 100. Because when I divided them, the original percentage unit canceled in a sense. There we go, 6.36%. Now you could look at, relative risk. Yeah, relative risk here. You see here, if I wanted to make that a percentage here, not for interpretation purposes, but to make my relative risk reduction easier to link, you see here that the relative risk reduction is just the relative risk minus my baseline 100%. So I have a 6.36% increase on top of what would be happening anyway if I took the vaccine or I didn't take the vaccine. Right. So let's just carefully interpret the relative risk reduction. If I Okay, so for one way of saying it is that my chances of getting the virus are increased by 6.36% if I don't take the vaccine. Period. We can also talk about the extra bit, but it's going to come up when we do number needed to treat, which is next. So there's no point in repeating myself here. Let's just jump to the next one. Number needed to treat, NNT. Okay, so the number needed to treat. Let's remember what that is. I don't memorize these calculations, to be perfectly honest with you. I have no idea what they are. But by understanding what I am saying with each of these statistics, the calculation should be fairly straightforward. If I just understand what am I trying to say, and it's linked to the initial interpretation. So what am I trying to say with the number needed to treat? Well, I'm trying to see that if people took the vaccine, let me rephrase that as a risk factor. if people weren't exposed to the risk, everyone took the vaccine, there's a chance of still getting the virus. It's the 37.04%. In addition, if some people choose to be exposed to the risk, not necessarily a choice, but if people are exposed to the risk, in this case by not receiving the vaccine, their chances increase by 6.36%. So of this group, there's a portion, 6.36%, that for which the virus could have been avoided by giving them the treatment. So that 6.36 is a percentage. That means 6.36 people in 100. So in order to figure out the number needed to treat, I have to calculate. I'll do it over here because it uses the percentage ones. I like the percentage version, but you can of course do the decimal version as well. Didn't like that. Why not? Oh, because in my Discord calculator, I use two equal signs Excel. Okay, so remember the unit here is people. So 15.71 people I need to take randomly from the exposed group, those that don't have the vaccine, that haven't taken the vaccine, in order to statistically catch one person that will test positive. I can then give them the vaccine. Sorry, I can give these 15 people the vaccine, and one person that would have previously gotten the virus now will. So I'll round it up to 16 people. Right? Different ways of saying the same thing. Saying the same thing. And last up, we have the odds ratio. Now for the odds ratio, I want to calculate the odds, maybe two D's, right? Odds for my exposed group. Now I'm just going to calculate the decimal. I guess you could do both. Row. Let's write it in the percentage row. Can I do 130? Yeah, I can. Okay, good. And then the calculation will be, I'll still take the cells, right? I won't copy the numbers. 130 divided by 200. The odds of getting the virus in the exposed group not taking the vaccine is 130 to 200, or standardized 0.65 to 1. So I like to write the odds as well in sort of the original form, help myself, and the odds of getting the virus while receiving the vaccine as well is 50/85. That standardized is the 50 divided by the 85, 0.5882 to 1. Right. Just have enough space here to fill in our last one, which is the odds ratio, which will then be simply the odds of exposed or the big one divided by the small one in the same way the relative risk did it, divided by the odds of not being exposed to the risk, receiving the vaccine, 1.10. So you see here, in contrast to the previous example, which of course I assume you watched that video, there the odds ratio and the relative risk was quite different. quite different, and the odds ratio sounded much more scary and much more impressive, even though they were saying the exact same thing. It's our interpretation, really, that is a little subjective, unfortunately. Here, the effect of the vaccine based on this information is very small. Small. It's only a 6.36% uh, increase. Uh, it's only 2.3-ish% on top of my chances that would have happened. I say sort of regardless, assuming everyone can get the vaccine. 6.36% increase is relative to the base, right? Don't get confused between the absolute risk reduction and the relative risk reduction. Regardless, it's a small percentage, right? And that very small effect of the risk factor will correspond to the odds ratio being very close to the relative risk. And in this case, let's just interpret the odds ratio. The odds of getting the virus when you don't receive the vaccine is 1.1 times more than the odds of getting the virus if you do receive the vaccine. Saying the same thing, except in the odds language rather than the more direct and easier probability language. But it's the same thing. So there's not much issue with presenting odds ratio versus relative risk because they are so close together. My potentially subjective impression when I see these numbers is the same. It's the same. But when the effect of the risk factor is quite large, then, or the larger it gets, the more the odds ratio will differ from the relative risk. And then, as an author, potentially, I have to think about how my information is perceived and what I want to present. Because unfortunately, when it comes to odds versus probability, people don't necessarily uh, have the correct understanding of how these two are different yet say the same thing. All right, so that wraps up this example. Make sure you can calculate all of these. I strongly recommend familiarizing yourself with the spreadsheet. It is so convenient. If you compare this one to the previous one we did by hand, there is no contest. There's no comparison between the two. This one's way better. And also make sure you can interpret every one of these statistics that we calculate. If you're not sure, I didn't write it down to save time, but I did interpret every one verbally. So please go back and make sure you can do that as well. All right, until next time.